This is Mr. Martin. These are video notes for Pre-Calculus Advanced. This is day 2 for inverse trig functions. We're going to be looking at a bunch of examples of composite functions in this video. So this is really going to check to make sure you understand the concept of inverses and how they relate to the original function. So anytime in these examples, if you want to pause the video and see if you can work out the example on your own, feel free to do so, and then just restart to check what you've done. So inverse functions, normally they're just going to undo each other. So for these first couple examples, if you notice, we've got the cosine inverse of the cosine, and we've got the sine inverse of the sine, and the tangent inverse of the tangent. So with a quick check, we can make sure that these are going to work. So the first thing that we need to do is look at the angle and make sure that that's in the right domain for our inverse function. So 4 pi over 7, when we're working with cosine inverse, we know we have to be on the top half of the circle. So the top half of the circle goes from 0 to pi, and if we're talking about sevenths, that would be 7 pi over 7. And 4 pi over 7 is going to be somewhere over here. And so we're in the right part of the circle when we're talking about cosine inverse. So the cosine inverse of the cosine of 4 pi over 7 is simply just going to be 4 pi over 7. Okay, remember, anytime you see this cosine inverse or arc cosine or any of the other inverses, you want to be thinking, okay, I'm looking for an angle. So I can see I'm looking for the cosine inverse, and we end up with an angle value. Alright, moving on to number 2. We've got negative 2 pi over 5. So this would be 5 pi over 5. And this would be 2.5 pi over 5. So negative 2. 2 would be right about there. So negative 2 is going to be somewhere around there. Negative 2 pi over 5. And we can see that that is in the domain for inverse sine. It's on the right part of the unit circle between pi over 2 and negative pi over 2. So the answer for this is just 2 pi over 5. So again, inverses, they undo each other. Sine inverse and sine cancel each other out basically, and we're left with the angle. Again, we just need to make sure that the angle is in the right part of the unit circle. And we'll look at that a little bit closer once we get to example 4. So tan inverse of the tangent of negative 3 pi over 8. So this would be 8 pi over 8, which would make this half of that, so 4 pi over 8. So negative 3, since 3 would be right about here, negative 3 is going to be right about here. And tangent has to be on the right half of the circle, so that's okay. So this will just be 3 pi over 8. Alright, now when we move on to number 4, we can see we have 11 pi over 7. So let's figure out where that is. So this would be 7 pi over 7. That would be 3.5 pi over 7, which would make the bottom here 10.5 pi over 7. So 11 pi over 7 is going to be somewhere right over here. Now, when we're dealing with cosine inverse, we know that we have to be somewhere in the top half of the circle. And the angle that we're working with here is not in this highlighted area. But there is another angle which will have the same cosine value. So when we're talking about cosine value, this angle has a cosine value somewhere right over here. Okay, and if I continue this up over to there, this angle in the first quadrant would have the same x value. So if we're looking at the x values of these 2 points, this x value is going to be the same for both of them. X value here, x value here, they're going to be the same. We're not really too interested in what they are. We're just kind of interested in what this other angle in the first quadrant is going to be that has the same x value, because that's the one that we can find the cosine inverse of. So if this is 11 pi over 7 here, that means that we've got 3 more pi over 7s to go before we get to 2 pi. actually 4 more pi over 7s. So that means if I go 4 pi over 7 this way, I'll get to an angle that has the same x value, which means that the cosine inverse of the cosine of 11 pi over 7 is going to be 4 pi over 7. Okay, so make a little correction there. Working on adding, we're looking at 14 pi over 7 here. So to go from 11 pi over 7 to 14 pi over 7, that would be 3. So that means that we would have to go 3 up this way, which would be 3 pi over 7. Okay. Moving on to number 5. We've got 7 pi over 8. So I know that this would be 8 pi over 8, which means that 7 pi over 8 would be somewhere over here. And since we're dealing with sine inverse, I know I've got to be on this part of the circle, and this angle is clearly not on the right half of the circle. But I can look at another angle that has the same sine value. So if I draw straight across here, this angle here will have the same y value as 7 pi over 8. So we just need to figure out what that is. Since this is 1 pi over 8 away from the x-axis here to 8, this has to be 1 pi over 8 away over there. So then the answer here would be 1 pi over 8. Alright, we're looking for an angle in the right part of the circle, or the correct part of the circle, that has the same y coordinate, because we're talking about sine and inverse sine. Alright, number 6. We're talking about pi over 9, so this is 9 pi over 9. This would be 4.5 pi over 9. So since 7 pi over 9 would be somewhere over here, negative 7 pi over 9, we just kind of reflect that over the x-axis. This would be negative 7 pi over 9. And remember, when we're dealing with inverse tangent, again, we have to be somewhere on this right half of the circle. This angle's not on the right half of the circle, but there is another one that will be in the right half of the circle over here. So we just need to figure out what this angle is here. So since I'm 2 pi over 9s away from the x-axis here, I've got to be 2 pi over 9 away from there, which would make this angle negative, because we're going clockwise, negative 2 pi over 9. Alright, so if you had any questions about those, make sure that you ask. And that's going to be the end of this video. You can move on to the next video. And if you have any questions, make sure that you check in with me the next time you see me.